Hello, you are welcome to New Focused Approach to Mathematics Basic 8. This is the revised edition. In this video, we are looking at solving exponential equations. This lesson can be found in page 75. So, in our previous lesson, we did application of indices. And here we want to look at equations involving indices or exponential. Now, before we do that, we need to get some rules clear. Rule number one. Anytime you have two indices with an equal sign in between and they are of the same base, we always equate exponent so that our s becomes 3. Again, if I have 3 to the power a or 3 exponent a is equals to 3 exponent negative 12, since the bases are the same and we have equal sign in between them, then we can say a is equals to negative 12. Now, rule number 2, that will help us to solve exponential equations. If you have a exponent 3 is equals to 5 exponent 3, according to the rule number 2, if the exponents are the same, we always equate bases. And so the rule number 1 says that if the bases are the same, we equate exponent. And here, if the exponents are the same, we equate the bases. Another example can be this. If I have x to the power negative 2 is equals to 17 to the power negative 2. Since the exponents are the same, I can say s is equals to 17. Let's look at another example. Say I have x minus 3 all to the power 32 is equals to 13 to the power 32. Since the exponents are the same, I can easily write x minus 3 equals 13, and solving for x, I will say s is equals to 16. Now let's see how we can apply this in solving questions. If you are given the question like this, find the value of x, given that 2 times 2 to the power 3 divided by 2 to the power 2 is equals to 2 exponent x minus 1. And so here we have the multiplication, the same base, here's power exponent 1. So that is going to give us 2 exponent 4 divided by 2, which is equal to 2x minus 1. And since the bases are the same and we are dividing, we can also write 2, we subtract the exponent, so then we have 2 here is equal to 2 exponent x minus 1. And then according to the rule that we just saw, if the bases are the same, we equate exponents. So 2 is equal to x minus 1. And 2b equal to x minus 1. If you try to make x the subject, we have 2 plus 1 is equals to x. Therefore, s is equals to 3. And that answers the question. Let's try another example. Say you are given 3 to the power n plus 2 minus 27 equals 0. Want to find the value of n. So here we can group like terms by having n2 is equals to 27. Because it's minus here, it will be plus. Now I can keep my 3n plus 2 and change this one to indices. Since I have base 3 here, let me see if I can write 3 to the power something that will give me the same as 27. And that is 3. Now I can see now that the bases are the same. There is equal sign in between them. So I can say n plus 2 is equals to 3 by equating the exponent. But so do we, making n the subject, we can have 3 minus 2, then n is equals to 1. So for this very question, n is equals to 1. Let's see more application questions. The population growth of fowls in Mr. Jesse's farm is given by 4 exponent x minus 2, where x is in months. Find the number of months needed to have a fowl population of 1024. Okay, find the number of months needed to have a fowl population of that. So the growth of the fowl is equal to this. So if you want to find the number of months, which is the x, then we equate this one to the total number, which is that. Now, since we have 4 exponent base, we can also change 4 to become 2 exponent 2, then times the existing exponent. Again, 1024 can be 2 to the power 10. That means 2 times 2 times 2, 10 times will give us 1024. Now, since the bases are now the same, I can now write 2 into bracket x minus 2 equals 10. When I expand this, I have 2x minus 4 equals 10. So if you group like terms, we have 10 plus 4. 2x is equals to 14. Dividing both sides by 2, we have x is equals to 14 divided by 2. And so x becomes 7. And that answers the question. Okay, let's see the last example. The quantity of fuel energy needed at a steel factory is given by the exponential or indices 3y plus 1, where y is in days. After how many days would the country consume a total fuel of 100 to the power 14? Right. So we can have this as 10 to the power 3y plus 1, and this 100 to the power 14, 100 can be written as 10 to the power 2, then all to the power the 14. I can maintain this one as this, and then this will be 10 to the power 28. Now, since the bases are now the same, I can equate the exponent as this. So 3y is equal to 28 minus 1. 3y is equal to 27. Dividing both sides by 3, then we can have y to be equal to 9. Right. I'm sure based on the concept I've developed with you about the equation of indices, you can go ahead and solve more questions and it will help you understand better. Thanks so much for watching.